Indices, you might be wondering, indices is actually a plural word. It is coined from the word index. Index. And index actually means raised to power. That's the meaning of index. And it can also be known as exponent. Exponent. So they are all same word. So all this put together is what gives us indices. So indices is actually in plural form. Index is the singular form. So it actually talks about power. So everything we'll be talking about from now on in this series is going to be concerning power, exponent, power, indices. So for instance, we have a raised to the power of m. This is our index. This is just a value raised to the power. So this is index. So this is what we'll be focusing on in this topic. So quickly, let's see the laws of indices. Several laws when it comes to indices. So laws of indices. So when it comes to indices, today is the addition law. The addition law. This law is very simple. When you are multiplying two same base, or two same quantities, you add the power. That's all. When you're multiplying two same quantities, you add the power. For instance, let's take for instance, this is m times a raised to the power of n. Because you are multiplying this same base, what do you do is that you add the power. You just pick one of the base and you add the power. So that will be a m plus n. So this becomes the addition law. Or we can pick one example there. For instance, you have 4 a raised to the power of 4 times 4 a raised to the power of 5. What you do is that you multiply this. That will be 16. These two, they are same, so you pick one and you add the power. That will be 4 plus 5. So we're having what? 16a raised to the power of what? 9. So this is 9. This is not a, that's 9. For the sake of explanation, you can fix any quantity there, any alphabet there, and you will get that same value. So this is 16 a raised to the power of what? 9, following through the addition law. Quickly, let's talk about the subtraction law. In the subtraction law, when two or more same base are divided, you subtract the power. That's all. When two or more same base are divided, all you just need to do is to what? Subtract the power. So the subtraction law goes with division. Now, okay, the first time we use a, let's use b now. Let's say b raised to the power of m divided by b raised to the power of n. Because there's division here and there are same bases, we pick one while we subtract the what? The index. So that can be b raised to the power of m over b raised to the power of n. What you do is that you pick one, that's b, then you subtract the power, that's m minus n. That's all. Let's picture an example. Let's say 18 m raised to the power of 6 divided by 3 m raised to the power of 3. So what that would be, from the law I just stated, that can be 18 m raised to the power of 6 3 m raised to the power of 3. So 3 here 1, 3 here will give us 6. So that will be 6. This is m raised to the power 6, m raised to the power 3. You pick one of the m, that's m. For subtraction law, I said you subtract the power. So that's 6 minus 3. That will give us 6m raised to the power of what? 3. Following the subtraction law. The zero law. Yes. Zero law. What's the zero law in indices? The zero law actually states that whatsoever alphabet numbers that are raised to 0 is equals to 1. Perhaps that number, provided that number is not 0. For instance, what do I mean? We can have numbers like this. B raised to the power of 0 is 1. 5 raised to the power of 0 is 1. So any number or letter raised to the power of 0 is 1. Provided that 0 is not raised to the power of 0. This is unacceptable. This is it cannot be divided. It is not allowed. Let me use that word. It is not allowed. But every other number, be it negative, be it positive, once it is raised to the power of 0, it is 1. So this is called the zero law. For instance, we can have something like this. M minus 3 times m raised to the power of 3. So that will be we pick one, right? This is the addition law. We pick one, we add the power, right? That will be minus 3 plus 3. So minus 3 plus 3 will actually give us 0, and that will be equals to what? 1. So this is the law that guides that any number raised to the power of 0 apart from 0 is equals to 1. Negative index law. What does it mean? When a base is raised to the power of a negative index. So we call that the kind of law that you apply is called the negative index law. For instance, let's say m raised to the power of 3. So now to remove this negative value, to remove this negative sign, you can include 1. For instance, it can be 1 over m raised to the power of 3. So the introduction of this 1 over takes away the negative sign. So that is negative law. So but in fraction, okay, let me give you another example. Let's say m raised to the power of minus a. What that means is that introducing 1, it becomes 1 over m raised to the power of what? A. Now in terms of fraction, all you just need to do is to interchange both values in terms of fraction. I'll give you the example, an example now. In terms of fraction, let's say we have a over b. Then we have minus 3. Very easy. To remove this negative value, when I interchange these letters, negative value will leave automatically. So for instance, it can become b over a raised to the power of what? 3. So you can see that the negative sign is gone. So this is called the negative index law. We have b minus 3 times b 9. So let's apply the rules to this. B raised to the power minus 3, of course that will be what? 1 over b raised to the power of 3 times b raised to the power of 9. This times this, you'll be having b raised to the power of 9 over b raised to the power of 3. We'll apply the subtraction law. Then we'll pick one of the bases. That will be b. Then you subtract the power, that's 9 minus 3. We'll be having what? B raised to the power of what? 6. So you can see that the negative index law is holding here. Quickly, let's move on to another law. So this law we want to talk about product law. Product law. I think that's number 5. Product law. The product law actually talks about having when a power is raised to another power. So when a power is raised to another power, all you just need to do is to multiply both powers. When a power is raised to another power, to express or to simplify that, you just multiply those powers. I'll give you an example. For instance, we have a is raised to the power of m or raised to the power of n. So all you just need to do is, that will be this times this, m times n. That will be a raised to the power of what? Mn. This is actually called the product law. So I'll give you an example now. So for instance, we're having minus am raised to the power of 2 or raised to the power of what? 4. So all we need to do is that will be, now you can see that this m raised to the power of 2 is affecting only this m, it's not affecting a. A is actually raised to the power of 1 here, but all of them raised to the power of what? 4. So you can break them down. This is minus a raised to the power of 1 times 4. Then this is m raised to the power of 2 times 4. So of course, what we're having here is minus a raised to the power of 4, m raised to the power of what? 8. So because this is when the negative value is raised to an even power, that negative value automatically disappears, except it is raised to an odd number, raised to an odd power. But this is an even power, so what we'll be having there is a raised to the power of 4, m raised to the power of what? 8. So you can see that. Let's go to another law quickly. So this law I want to talk about is the fractional law. I think that's number 6 or 7, I can't remember. So let's say the fractional law. So but I want to explain this fractional law with roots. I want to explain this fractional law with roots. For instance, we're having a raised to the power of m over n. Now, this is the power. This is the root. This is the power, this is the root. What do I mean? This is, let's say 1 over 2. Now, this is the root. This is the what? The power. So we can actually express it as root a raised to the power of what? 1. Root a raised to the power of 1. So this is or we can say square root a raised to the power of 1, because 2 is actually square root. Now we have cube root, fourth root, fifth root, so on and so forth. So for instance, now if I write 2 over 3, what do I mean here? What I actually mean is that this is a cube root expression now, raised to the power of what? A square. So what that means is that will be what? Cube root a raised to the power of what? 2. Let me give one more example. Let me say this is okay. Let me simplify this. Let me give an example. So for instance, we have 16 2 raised to the power. Okay, Let me picture another thing. 3 raised to the power of 2. What this means is that will be square root 16 raised to the power of what? 3. That's the meaning. So what's square root 16? What's square root 16? That's 4 raised to the power of what? 3. So you can see how easy this is, right? So we can also continue. Let's talk about the fraction now. So like I told you before, I think I've explained this part. For instance, when it comes to a fraction, we can actually say maybe we have 16 over 3. I've said this before. We have minus 4. I said to remove this negative value, this negative sign, we can just interchange this. Becomes 16 or raised to the power of what? 4. Right? So all these are laws of indices.